Hello students, today's our topic is photoelectron spectroscopy. Photoelectron spectroscopy involves the ejection of the electron from the surface of the atoms or molecule by the bombardment of the photon. These ejected electrons are known as photoelectron, and the concept of the ejection of electron is based on the photoelectric effect. The concept of the photoelectric effect was originally observed on the surface of the easily ionizable metals like the alkali metals when they are exposed to the UV radiation. It has been observed that not any electron can be ejected regardless of the intensity of radiation unless the frequency of the incident radiation exceeds a threshold value. This is also known as work function, and it is characteristics of a metal. We can see here a picture where we see the work function for a metal is given, and this is the energy supplied by the incident photon. And here it is clear that the energy supplied by the incident photon is less than the work function of the metal, hence no photoelectric here is observed. Whatever we are using the intensity of incident photon. But in this second case, here we have increased the frequency of the incident photon, and it is now exceeds the work function of a metal, and then the photoelectric effect can be observed. The first part of this incident energy will be used by the metal for the ejection of electron, and rest part will be taken up in the form of a kinetic energy. Here we can also write the following result as per the energy conservation rule. Here the total energy supplied by the incident photon h nu is equal to 5 plus 1 upon 2 MeV square. But in the case of the gas phase molecule, this work function phi can be replaced by the ionization energy, and then we will get the following result. The kinetic energy of the ejected electron increases linearly with the frequency of the incident radiation, and here from this curve we can see that a curve is plotted between the kinetic energy of photoelectron and the frequency of incident radiation, and it is rising linearly with the frequency of incident photon. And here we have take the three metal atom for which the work function value are also given. Rubidium have the 2.09 electron volt, potassium has 2.25, and sodium has 2.30 electron volt work function value. Here is the theory of the photoelectron spectroscopy. In the above case, where the surface of the metal is irradiated by the photon, we can see it involves actually the hitting of the photon to the valence shell orbital electron, and by getting these energy they are immediately comes out of the surface in the form of photoelectron. This technique, in which the UV radiation is used as a source of incident radiation is known as the UPS, ultraviolet photoelectron spectroscopy. Whereas in the second picture, if we are interested in studying the energy of core orbitals electron, then we will use some more powerful sources like the X-rays. Here we have used the X-ray beam to remove the electron from the core orbital of a metal, and this is the ejection of the electron. Then this technique is known as the XPS, X-ray photoelectron spectroscopy. Here is the experimental part of the photoelectron spectroscopy. We have in this spectroscopy the following part. First one is the radiation source, a sample holder, the energy analyzer, electron detector, and a low pressure system up to 10 to the power minus 7 Pascal, which is required to clean the surface of the metal and for inelastic free path of the electron inside the system. Here there is a schematic diagram for the PES. This is the target chamber where the photon are bombarded on the sample, and this is the removal of the photoelectron. They will comes out from this exit slit into the electron energy analyzer. A variety of electron energy analyzer here is can be used. Here they can be parallel plate analyzer, or they can be cylindrical mirror analyzer, CMA type analyzer. Actually the work of the analyzer is like a monochromator which disperses the electron or photoelectron on the basis of their energy and send them to the detector where they are collected and recorded for the analysis in the form of a photoelectron spectrum, in which the curve is plotted between the number of electron collected per unit time and the kinetic energy of the photoelectron. Thank you.